Welcome to the Mobile Application Framework YouTube channel. My name is Frank Nymphius and I'm from the Oracle Development Tools and Mobility Tools Product Management team. In this episode I talk about programming against the data control. And I will also show you the use cases why you want to do this. Before I start, let's have a look in the overall architecture just to give us an idea in which context this episode is in. So this is the architecture of accessing a remote service through data controls and displaying the values on the user interface. And the area that we're talking about is just the data control access. And you see that we're not only talking about the SOAP data control or the REST data control, we also talk about the POJO data control, because any data control can be accessed from Java. One use case is where you need to get access to data without actually creating a visual representation of this data, like not having department's information displayed on an employee screen, but needing to get information about the departments. From a managed bean, what you can do is you can access the data control that gives you access to that information and query the data directly and do whatever the business logic wants you to do with it. And then you can implement local caching strategies. Now, if it's not a managed bean, but if it's, say, a POJO that you expose as a data control, then this POJO could act as a man in the middle between the user interface calling out to a SOAP service. Now, every data that comes from the service can be cached either permanently for offline storage, so you can use that within a SQLite database, and there's an episode just about that later on. Or you can have temporary caching, which is that the POJO itself will hold the data, and for every subsequent request, first we'll look if it already has the data or if it needs to fetch the data from the remote service, just to improve the user experience in terms of performance. And then, of course, you can work with the data, because if you're sitting in the middle there, you can filter the data, you can aggregate data, or you can even sort the data. And on the way back, if a user requests a SOAP service or sends information to the service, you can validate that. So there's a lot of possibilities and flexibility and dynamics that you get out of having this man-in-the-middle approach for invoking data controls. And for this, Java is the option to do that. So how does it work? Well, first of all, and probably most important, when you invoke a data control, that data control must have a reference in its data binding CPX file of the project that you're working in. Now, the easiest way to create such a reference is that you take an attribute, a method, or whatever from the data control palette and drop it quickly onto a view of your project. Now, this will create the data binding CPX file in case it doesn't exist, or if it exists, it would just add the data control reference in there. So it will have an ID pointing to the data control. In the end, you can just go on this in the same step, in the same working step, and delete the UI component that gets generated out of this, and even delete the binding layer. What remains is the entry in the data control and the data binding CPX file. So that's what you need, because you're just dealing with that. And then there is a utility class called the ADFM Java Utilities class, and this class provides you a method to invoke a data control, pass arguments in, but also retrieve a response. And then you need a Java class to call the data control from. Now, as mentioned, this could be a managed bean or the man in the middle, in which case you have the POJO that will do that. Or, and there's a special use case for that, it's a standalone Java object, which would use, for instance, for the JavaScript to call back into a data control. Now, I cover that specific case in a later episode where I talk about the POJO data control more in depth and detail. So let's have a look at the code example. So first of all, we create 3 lists. Even if you have no arguments to pass, we produce empty lists, because that is what we will pass in the case that there are no arguments. And then to invoke the web service, first of all, we specify a result object of type GenericType, because that is exactly what we're expecting from a SOAP request. And then in the try catch case, you would then call ADFM Java Utilities invoke data control method. And here you specify the ID of the data control as you find it in the data binding CPX file, The second argument usually is null. It's only would be not null if there is a nested instance of a data control, which we don't have by default. So put in null here for now, and probably for all of your projects. And then I call a method on that SOAP data control. And that would be a method, you know, if I'm talking to a POJO data control, that also would be a method then exposed on the POJO data control. And next, I pass the 3 list arguments, one for the names, one for the values, and one for the types. And that's all I need to do to invoke the service and to get my information back. So now we need to talk a bit more about the data conversion, because so far I said that everything will be ending up in a generic type. So the generic type actually can be serialized into Java objects. Now I mentioned that. So it will map the SOAP payload to any custom entity or data object. And there are some rules for that. First of all, we talk about data objects, but these data objects, as said, in the web world usually are referred to as entity. So what this data object will have to do is it will have to provide the same structure as the generic type, or actually the SOAP response. So if the SOAP response is a collection of departments, and if the department has a department ID, department name, location, and manager ID, then my object that I want to pass into should have department ID, manager ID, location ID, and the department name. Because this way we can use a utility class I'll show you later to just dump the generic type into the entity, in the data entity. If the generic type contains subcollections, like you're requesting departments, and with the departments you get nested objects of employees, then this structure needs also to be mimicked in the data object. So you will have a nested collection in this data object representing, for instance, employees. So the structure of your data object must match to the payload. What if it doesn't? Well, if it doesn't, if you're missing out on one of the properties, it will be just ignored. So the parsing will happen, but this property that we find in the payload but don't find in your Java class, that will be ignored. So it will not cause a problem. So here's an example for a very simple department object. So the data object department with the attribute that I just mentioned, department name, ID, and so on. And then you create setter and getter for it, because this is what would make the attribute a property. And we need to work with properties. And to do that, you will just right mouse click into the source code editor, choose generate accessors, and then it will show you the list of properties it finds and ask you to create set and getter for it. You just check them all and hit OK, not before checking the checkbox that you see at the bottom, which generates property change event. Now, the property change events are there to notify the framework about changes in an entity object. Now imagine that in Java code, for instance, you change the department ID of one of the departments or the department name. Now, if that department is visible on the screen at the same time, you want to make sure that the screen automatically refreshes. And that is what it does through the property change notification. To convert the generic type into a Java object, there is a class, and that is specific for SOAP services. It's called the GenericTypeBeanSerializationHelper. If you work with a POJO data control, as mentioned, typically the POJO data control will return a collection of entities. So you can straight pass this into this collection, and you don't have to go this intermediate step of working with the generic type, which is very SOAP specific. But anyway, I give you the big picture, and you paint the small picture out of it. So you have a generic type object, and that generic type object needs to be passed into your custom data object, and for this it uses Java Bean reflection. So that means it looks like what do I find in that custom entity and tries to find the same in the generic type. Transient attributes, they're completely ignored. So if on the server side the payload that you send back with a SOAP request is a non-entity payload, which means that it's like a property that has an aggregation and it is flagged as transient, then that will not be reflected. So only non-transient attribute will be reflected in the parsing, and that gets then passed from the generic type into the Java object. So here's an example. So just going for the little bit that really demarks the conversion. So I have a department's entity object here, and this department's entity object should be populated with the results that I find in a generic type. Now in this case the generic type is considered to be not a collection but a single object of type department. So what I do is call GenericTypeBeanSerializationHelper, and then I pass two arguments in it. The first argument is the department, so the name of the class, and the second one is the payload, or is the generic type that I get as a response. Now, however, if you're calling a SOAP service that has a collection of departments that it returns, you have to iterate over this collection. I said the generic type mimics a complete payload, and if the payload is a collection, then that also is reflected. And the next code slide will show you how that works in detail. So here I do have a collection that I expose in a POJO, which is meant to become a POJO data control, and it allows you to call get all departments and returns a collection, an array of departments. Now the first thing it does is it gets the generic type as a result. And once it has this, we actually need to create a departments list, because this is how we collect all the information that in the end we return as an array. So the next step then is, once we have that, is to check the result that we have, so the generic type, for its attribute count. Now, as I said, if the top level generic type is a collection, then we can get the attribute count, which will then represent other generic types. Now, these generic types could be just objects or other collections. I mentioned that before. But that's something that you need to figure out based on your knowledge about the SOAP response. So in this case, it's just a collection of departments, so I can iterate over the attribute count. And then what I do is I get another instance of generic type and get this out of each entry in that collection. And then I do exactly the same as you've seen on the previous slide. I just say department class and then entity generic type. So that's basically how I bring the two together, and they're getting passed accordingly then. And then in the end, I just call toArray on my list. Okay, so what we want to do, just to explain this a bit further, is we want to have a look into the weather report that we built before. And for this weather report, what we want to do is we want to use now a Java approach. So we'll create a POJO data control to invoke the SOAP service. So this way you get two sides of the same story. The purely declarative side, where I directly hook up the user interface to the SOAP service, as I did in a previous episode, or just with this man-in-the-middle approach, as I like to call it in this case.
This is JDeveloper 12.13 with the MAF extension installed. In a previous demonstration, I showed you how to create a SOAP data control based on a remote SOAP web service. And I want to continue with this example here to show you how to access the web service data control from a Java bean and then expose the Java bean as a data control on its own, which will give you the ability to sit in the middle of the communication between the user interface and the remote service for caching data, for filtering data, sorting data, whatever you want to do based on your business requirement. I did create the service data control, so the SOAP service data control, and I did create it based on a URL that I've found pointing to a weather web service on the internet. And I used that in my previous example, so I'm not going into detail here. The most important thing is that I created a POJO infrastructure, and this POJO infrastructure that I created has three types of classes that I want to introduce before explaining how you work with this. So first of all, I created my own helper class, which I called the SOAP service invoker. Now this just wraps the invocation of the SOAP data control from my application logic, and I just did this for brevity, so I have it easier to explain to you how that access path works. Then there is a weather response. Now this is an entity. Now the information I'm getting back from the SOAP service is a list of attributes which I can wrap in a response. Now this weather response is something that I use in my code to have the framework stuffing in the response payload, which is XML, turned into a generic type, and then turned into the weather response object for me to work with that, which is easier for a Java developer to work with a Java object than to work with the XML payload directly. And then I do have another class which I flagged as the data control. Yeah, so this is the class actually that exposes the method to invoke the service, but also gives me the return values for accessing the weather information and also to build the search form. So let's start with the SOAP service invoker. Again, you probably don't need that. It's here for me to better explain how things work. So this SOAP service invoker has one method called getWeatherForZip. The web service has three methods when I run it and create the data control, and one of these remote methods that the service exposes is getWeatherForZip. In my case here, I wrap this in this class, so I expect the name of the data control, which is the ID as the data control reference will have in the data binding CPX file. You see the data binding CPX file created here, and there I do have a ID for the reference to the data control. And I explained this in a previous recording where I talked about the binding, so just in case you haven't watched that episode, just go back and have a look there. And I expect the zip code to be passed into the method. The structure of invoking a web service through the SOAP data control is that I need to create three arrays of type array list here. And this will have a list of argument names. So I only have one argument, which is zip, and I have to take the name of the attribute as it is expected in the WSDL file. So I can read it up there. And then there is a value. In my case, it's a zip code that is passed in, like 90922 for Beverly Hills. And the type of the arguments also has to be passed in, and this is a string class. If you have more than just one, you would add another param names, add, and then the name of the argument, same for the value and for the type. So this is how you prepare the arguments to be passed to the data control, for the data control then to pass it along to the web service. And then I do have the actual call to the web service. The response I get from a SOAP service is of type generic type. So this is the internal framework class that MAF passes all of the XML payload that comes from a web service into. And then there's a utility class, ADF, MAF, Java utilities, and this has a method, invoke data control method. And this requires the ID, the reference to the data control. Null is something that you would commonly use with a web service. So this is a special case where that would be non-null, which is when the data control is nested, which I don't know what the use case for that would be. And then there's a method called getCDWeatherByZip. Now this is the name of the method as it's exposed on the web service. And here I pass parameter names, values, and types. When I run this line of code here, the result object will be populated with a generic type, so an object. And this generic type contains the structure of the returned payload. If the returned payload is flat, like in my example where I just have one single object that comes back, then it will just contain the attributes as a structure. It has nested collections, then there will be nested generic types in it. So in the next step, what I want to do is I want to have the MAF framework to pass the generic type content into my data object or my entity, which is what the next line of code is doing here. So I have a weather response, and this weather response actually uses the GenericTypeBeanSerializationHelper, which is a helper class in MAF, and now it calls from generic type, and it passes in the data object I want the result to be saved in, which is weatherResponse.class, and I pass the generic type object, which is result in my case, into this method. And then what I get out of this is I get a weather response object in my use case, which I return to the caller. So that's the first part of this. So this is how I invoke it. The weather response object, this is just a set of attributes with setter and getter properties assigned to it. And there's also one thing to mention here. You see that each of the setter invokes property change support via property change. Now this is in case that programmatically underneath the display, so to say, you're changing the value of one of the entities. So you want to make sure that the user interface in MAF becomes aware of that and that it refreshes. And this is created pretty simple. If I, for instance, create another property here, so let's call it private string test. So right mouse click, generate accessors. You see test here. I select test to create setter and getter, and then I do have the ability to automatically generate the property change support. So this is a setter method where I say notify listeners when property changes, and this will exactly generate the property change support I showed you in my existing attributes. So remove this and close it. That was my data object, which is the entity. And now coming to my data control. The data control now exposes an array of weather responses. So weather response is the data object, and I want to expose an array, so I can create a read-only form, or I can create a list view. The MAF framework uses Java 1.4 to this point in time, so we cannot expose a list, so we have to go with the array. So this returns a weather response, which is of type array, and it also exposes a method. And this method, if exposed on the data control panel, actually will allow me to create a search form with a zip as an input field and a command button to invoke that method. Now what it does is it builds my helper class, which is a SOAP service invoker, creates an instance of that, and now it calls getWeather4zip file. It passes in the data control ID, which is contained in the data binding CPX file. So it's weatherdc in my case, and it's quite easy. If you go to the data controls palette, there's a weatherdc entry here, so you know that that is the ID of the data control. I pass in the zip information. Now the zip information is actually an information that I have exposed as on the method. So when I drag and drop this, then the zip information is the input argument that comes from the parameter form. I then invoke the weather report. I get a weather response, and if the weather response is null because I passed in the wrong zip code, I will just return an empty array. Otherwise, I will just get my information returned from the SOAP service invoker class that I created. Now to create the data control, right mouse click on the class, create data control, and you see this wants to create weather POJO data control 1, and the reason is because this project already contains a data control based on the weather POJO. I could just remove the 1 here and override the existing data control, which would allow me to rerun it, to refine it, maybe to expose a different set of methods or additional set of methods to a data control. So then I hit finish, and now we see that's my weatherdc data control, which is the SOAP data control, and this here is my POJO data control in the data controls DCX file with the methods invoke weather service. I can go to the data control panel, and this data control panel also has the same set of data controls here. Here's my POJO data control, and here is the method. If I drag and drop this method onto an AMX page, then I can issue the search, and if I then drag this collection here, which is the result set, then I can create a read-only form that shows the weather report for the area that I have the zip code for.
So this concludes this presentation about programmatically access to data control by example of a SOAP service. In the next episode, I will explain how you deal with bindings and how you code against the binding layer, which is the principles that you would use to manipulate data in the binding that are at the same time visually displayed on a screen.